not a question to go on renormalizing. One has to calculate the things in absolute value. Either it comes and that's it. And it doesn't come, there is some physics missing. Because if you are, and one thing I believe I don't think it's working, so and I think one thing that is missing is you are renormalizing with the paying vibrations, and that is perfect. You should renormalize the paying vibration and all that with the surface modes, in particular because there are going to be coexisting states there, and probably that is going to change again your numbers. Whether they are going to make them bigger or larger, I do not know. But at that time, you would not have a single free parameter to talk.
Sure. So I mean, so far you have done that with the quadruple pair.
Extremely well taken. Thank you.
Okay, thank you very much. Yeah.
You have talked about the coupling of the pairing modes with the gamma octet, right? So would that spoil the simple view of the double charge exchange as a two-step process of uncorrelated transfer of
that's wrong, uncorrelated.
Yeah. So I mean, if I think of papers were written, I don't know, 30 years ago, or more, like Ben Bateman papers, he shows that the two-step process is crucial to get the transfer. Okay. So if you go by if you only by a simultaneous transfer, you get almost half of the cross section. But when you are in the two-step, you get practically all of the cross section. So I don't know if those data, because those calculations were performed, I don't know, 30 years ago, and the data were very, I mean, I don't know, it was only one or two experiments, but I probably know better than that. So there was a paper written in 80-something by Ben, and he was taking the Lilly data on the 2-neutron transfer, and he found out that the correlations are essential, but he didn't. Yeah, okay. Very good. He has a paper, you know.
You have a picture for your mechanism for double charge exchange, but I have the impression that in your model, the process goes through the exchange, the transfer of two particles and then two particles back, which is certainly there. I agree, but as Ørsted shown or tried to show or is convinced, this is only part of the picture, because you are just there is the other process, which is the one that interests the other people there.
I know.
This is only pictorial, but I have the impression that you mean a specific process, which is not the one that Ørsted is thinking of. And then you
maybe a brief remark on
you
this
will all the afternoon
discussion. You have a severe, or you might have a severe overlap problem, because you are starting with the pair in one part, in one nucleus, and ending up in a different one, and then the cross-section is scaled, so to say, or depending on the overlap of these two different representations.
Yes.
And that makes it very difficult to make general statements on.
No, this is what I'm saying, that until now, what we have been doing is to assume that there is a kind of semi-classical motion of the ions, and then orienting the ions in gauge space, producing the double transfer, and going to the final state, and then keeping right of the say, normalization or somehow relative normalization. That's all. I mean, but the other process, as Andrea said, is important. But I just wanted to pick up this continuum, how large it is. That's what I want to know.
As I said, I mean, this is very interesting to learn something about these pairing correlations.
Yeah, because I already know how much of the pairing correlation is going to the GT transitions in the two neutrino double beta decay mode. So if I can make the same statement about this contribution to the other process, I will have.
Just a comment to a comment, I think double charge exchange is not simply sequential two single charge exchange. I think it was here mentioned, and in my talk I speak about that. It's already almost 30 years where it was observed that this completely breaks down and gives some energies even for pion charge exchange that you cannot describe in one to the analog and from the analog to the second analog, and it's for uncorrelated nucleus. You have to correct for that. In some cases it holds, but usually not.
But
Last question.
no, but I think that comes exactly the point. I don't believe that neither Osvaldo believed in that diagram, in the sense that he says, I have to take into account pairing vibrations, or no, just wait. But then he has to calculate that. And to calculate that, he says, I do not know how to do that. I go to Ben Weinberg, or to anybody, or to our good friend Lenske, or whoever who can, and he would tell to you that you have 1% or 2% of simultaneous and 99% of successive, and that would come everything. And there is no way that by calculating. But the point is that you know how to calculate that within experimental errors. Within the uncertainties of the optical potential, you get the absolute cross-sections for the single charge. And consequently, that would break in the way you like. Well, there is no way it cannot. So when he says the two neutrons or the two, he's not saying that he doesn't believe that, because then he has to calculate. And when he calculates that, either he talks with Ben Weinberg or with me or with somebody else, and then would come the successive immediately, 99%. So you are completely right.
I agree with you too.
No, but what I'm trying to say, what I'm trying to say that is a big piece of the whole mosaic, and one knows exactly how to deal with it. Okay, only that.
Okay, I think this is certainly the key point of the whole story. And,